in any way. These are the different representation or two methods of representation for the same current. So here the final conclusion is arrow is the fundamental part of any definition of the current, how the current flows. That means in which direction the current flows is the matter. So coming to the current density in any particular conductor, so the current per unit area of the cross section is the current density, and the current density representation you can write it as J equal to I by A, and the unit is ampere per meter square. So it is a vector quantity in which you will have the direction. Now coming to the voltage or the potential. So absolute potential is the amount of work done to bring unit positive charge from infinity to that particular point. So we are not interested in absolute potential, but we mainly based on the potential difference only. So which is also known as a voltage between 2 points. If the energy required to move a charge of q coulombs from point A to point B in terms of joules, W joules, then the voltage between A and B will be represented as W by Q. So here W is the work done. So 1 joule per 1 coulomb. 1 unit of volt equal to. So here the volt is nothing but the volts is nothing but the unit for voltage, and here 1 volt is nothing but 1 joule per 1 coulomb. So to move 1 coulomb of charge from a place of A to B, the work done is 1 joule. So this is about the representation of 1 volt, and now coming to the voltage, how we can represent. So here one terminal will be represented by positive and another will be represented with negative. So you can consider either positive voltage drop or voltage rise based on the notations, representations. Now, next one is coming to the power. So here if you consider the voltage across any point or element, a small charge dq is moved through the element from the positive terminal to negative terminal within the time delta t. So the energy absorbed by those elements you can represent it as delta W equal to V into delta T. So if I consider this relation, in which you will get it dW by dt equal to V into dQ by dt. So here you can conclude that the rate of doing work is called the power. So this you can represent it as so P equal to VI. So here the relation power is you can represent it in terms of V into I. So unit of power is watt. So horsepower is also used for the unit power, which is 746 watts. Now coming to the next one is energy. Energy is the capacity of doing work, and it can be represented with the relation as voltage into charge. So where you can write it as V into I into T or P into T. So the unit of the energy is joules. And if I consider the practical unit, it is also represented as kilowatt hour. Next one is, if you go for any type of circuit, so generally power supply should be required. So the power supply systems are in any electrical engineering laboratories, you'll have single phase supply like 230 volts with 50 hertz frequency, and in which we'll have two wires. One is phase, another one is line wire and neutral wire. Line wire or and neutral, phase or line and neutral wire. Coming to the three-phase supply, you'll have the voltage of with 400 volts with 50 hertz frequency, in which you'll have four wires, three for phase or line, and one for neutral. Okay, so this is the single phase supply. You can represent this as, and regarding MCP and all, we'll discuss later. So these are the four lines. This is about the power supply systems. Now, when we are representing any element, the power or any values of current, voltage or anything will represent in terms of different multiples. So these are the different multiples with the prefixes like deca, hecto, kilo, mega, giga, like that. And sub multiples like femto, pico, nano, micro, milli, centi, deci, like that. So the corresponding symbols, the used symbols. Now, Coming to any circuit is a combination of different elements, and it can be either active elements as well as passive elements. Coming to active elements, so the element which supplies energy to the circuit is nothing but the active element. Passive elements is element which can only receive energy, which can be either it can dissipate, observe, or store it. It can be done in terms of a particular circuit if I connect different elements. So this absorption and storage or dissipation can be, absorption and storage can be done in the form of either electric field or a magnetic field, and dissipation in the form of heat. So these are the different elements that can be possible to connect the circuit. Now coming to the active elements, we have different types of active elements which supply energy to the circuit. Those are voltage source and current source. This is the representation of the ideal voltage source, and this is the representation of current source, ideal current source. Now if it depends on any other element, current or voltage, then it can be represented as control voltage source and control current source. These are the representation of active elements, in which ideal case as well as control case. Now, ideal DC voltage source is the representation, ideal AC voltage source representation, and ideal battery. This is the ideal DC current source and ideal AC current source. So, which are the different symbols which we can use while we are using the circuit for the representation. Now, if I consider the practical case, so every source will have their internal resistance, whether it is a voltage source or a current source. So if I consider the voltage source, it will have internal resistance in series representation. So this is the circuit where the total source is connected to the load. So the voltage source in series with the resistance. So an ideal source will have the total voltage continuously. It won't change with respect to time, but in case of with respect to load, but in case of the practical, it will not be same. So based on the internal resistance, the value of the source will be reduced. Now coming to this, the practical voltage source. Now coming to the practical current source, the current source in parallel with the resistance. If the circuit consists of the source and load, the source is current source. Generally in practical case, the current source will have resistance, but it is in parallel. Again, the same ideal source will have the maximum value, but in case of the practical, it will be changed with respect to the internal resistance. So you can represent the source with respect to load in this way. But if it is voltage source, this is the representation, voltage source representation, voltage source in series with resistance, current source in parallel with resistance. So this is the practical representation of voltage source and current source if it is connected to the load.